Hey, what's up, everybody? Just here with my son, Alex. Say hi, Alex.
Hello.
Alex has been getting into or finding interest in learning how to become an audio software engineer, and he's my son. And so I thought, what better place to start teaching audio programming than on the audio programmer? And we came up with this idea of me giving him lessons, and that we thought that it would be helpful for other people if we recorded the lessons and just put them on YouTube for people to check out. So other people that are learning audio programming from the very start can actually check these tutorials out and hopefully follow along. So we're actually going to start from the very beginning. So with raw C++, then eventually move into Juice, and hopefully start building our own little plugins and audio applications. So Alex has actually done a little bit of development before, so he knows some basic concepts, but I'm going to start teaching him as if he is just starting and he hasn't written a line of code yet. I think that'll be helpful for people that are just really getting started. So, what I'm going to do is I'm going to share my screen with you, Alex, and
All right.
we are going to do this. Okay. So, can you see my screen?
Yep.
Okay, great. So, this is what we're going to be talking about today in this tutorial. We're going to talk a little bit about what is audio programming. We're going to talk about why we use C++ for audio programming and audio software development. We're going to talk about downloading a integrated development environment, or what we call an IDE. We're going to talk about the structure of a basic C++ program, and we're going to do our very first C++ program. So the first question that we're going to talk about is audio programming, and we're actually doing an edit of this because I find that this is audio programming as a whole is such a huge area that we could talk about, and there are a lot of different ways that I could try to explain this to you. But we're going to talk about a specific area of audio programming that we call real time audio development, and more specifically, we're doing this more or less towards music tech. If you're developing like a audio software effect, or if you're developing a virtual instrument like a synthesizer, or if you're trying to stream music out of your speakers, that's what we're talking about. And the reason that we use C++ for audio programming is because in the hierarchy of programming languages, and I'm sure that you've probably heard of various programming languages called like Python, JavaScript, assembly, C, then you have C++. So there are the thing with audio programming is that this needs to happen in real time. So what that means is that the best analogy I could give to you is if you were playing a video game, and you know how video games now have wireless controllers, and you hit a button, the way that your character on the screen has to react, they have to react so instantaneously that it needs to feel very immediate, like there's no delay between when you press the button and when the character actually reacts. And that's the way it is with audio programming as well. So if you created a synthesizer or a virtual piano where you were hitting keys on a MIDI keyboard, you want that reaction and when you actually hear the sound to feel immediate, like it's a real piano. Okay, so that's what we mean by real-time programming. Now, there's a lot of detail that we can go into in terms of why C++ is the best language for this, but the best way that I could describe it for a person that's never done any sort of coding before is that it's a low-level language that's close enough to what we call assembly. Assembly is a language that is right above machine code. So you have machine code, which is the very the binary language that computers have to read your language and translate it into, which is just zeros and ones. Then you have assembly, which is an almost human readable language. So it's not a very readable language, but it's a level higher than machine code. Then you have C++. So C++ is very close, what they call close to the metal, meaning that it's a very low level programming language that allows you to have control, low level control, to control memory and control the operations of your computer in order to be able to control how your application actually runs. So, in order to actually type C++, you need a place where you can type it into. So, you can use pretty much any sort of text editor where you can compile that into C++ code. So, for example, I have what's called my console here, or which is kind of what you would see in the Matrix, okay, where you can actually type C++ code in here and actually compile it, and it'll actually compile. Okay, so if you're on a Mac, you have an application that's called console. Or what's called your command line. So you can actually type your C++ code in here in a certain way and actually compile it, and it'll actually compile. But a lot of people use what's called an IDE, or integrated development environment, to actually create their C++ code and actually compile it and build it. So there are various ones. I'll tell you some of the most common ones. So we'll talk about Mac and Windows in this case. So for Mac, I normally use Xcode. So Xcode, if you go to your application store, and you just type in Xcode, you'll see it here, and you can hit download, and it'll take a couple hours to actually download. And once you do that, then you can install some developer tools and things like that. But that's what most people use to develop on Mac. Then on Windows, you have Microsoft Visual Studio. So there's a big difference between Visual Studio and Visual Studio Code. So those are two different applications. So if we type in Microsoft Visual Studio, you can actually download it here. Okay, just like that. Just do the community one there. So it's a free download. So both of these are free. You don't have to pay for them or anything. Okay, and you download them. So Alex has already downloaded Xcode, and I have Xcode as well. And now, once you have it installed, then when you come to your window, so I'm just going to minimize this for a moment. So now it's about getting started with your C++. So what you'll do is when you first open up Xcode, you'll see a screen like this. It says, welcome to Xcode. And what we're going to do is we're just going to create a new Xcode project. Okay, so the big thing about IDEs is that they have a lot of functions that you don't really get with the command line. So command line is pretty bare bones. But the disadvantage of an IDE is that there are a lot. It's very big in terms of the things that you can do with it, all the options that you have. I mean, I might use 5% of the options that of the things that you actually see here in Xcode. It's a very big application, and I only use the very basics of it. Okay, so to start a new C++ application on Mac, you would go to select Command Line Tool, and we will just call this hello. And then the language we want is C++. We'll hit next. We will just save this to our desktop. I'll hit create. And then you'll come to this screen, And you don't have to worry about any of this, okay? What we just need to do is we need to go to our source file. So we know that the C++ file has the extension CPP. Okay, so that's how you know it's a C++ file. And I'll just click on there. And now we see all of this. Okay, so one of the challenges of teaching C++ to start off with is that even to do the most basic C++ program, it actually takes knowledge of a couple different areas. Okay, it's not the most straightforward thing. So what I'm going to do is I'm going to actually just erase all of this, and I'm just going to delete it for now, and I'm just going to start from scratch. Okay, so what we see here at the top, when you see these slash slash, these are what are called comments. So none of this code actually compiles or anything. Okay, this is just something for that. If the person that writes the code wants to leave a comment, they could just do a slash slash, and you could say here's a comment. Okay, if you need to do a multi-line comment, you could do that by doing slash star, and then you could say here's a very long comment, and we could just type on and on and on and on, and then whenever we're finished, we would end that with a star slash. Okay, so if we wanted to type a little paragraph here, we could just type that, and that'll be a comment for people. So that's not actually code that compiles. Okay, so what we need for any C++ program is we need a main function. Okay, so to do that, I'm just going to make one real quick. It's called int main, and I'm just going to leave it like that. Okay, so this main function is kind of like so if we think of our code as like a recipe that we're writing, so code is like a set of instructions, right? So, and we can think of main as almost like the paper that we're writing the instructions on. Okay, does that make sense, Alex?
Yeah, everything or the basics of the code going into the main
Yeah.
function.
So anything that you're doing. So even if you're playing, let's see, like Assassin's Creed or any sort of AAA, like the most complicated music application, most complicated video game that you can think of that's built in C++, it all comes down to this int main function, and there will be various loops and various things in here that prevent the main function from ending. So while your game's playing, it's inside this int main function. And when the int main function finishes, when it comes to this end bracket, then the program is complete. So we're going to talk a little bit about what is this int main function. Okay, so there's a few things that are maybe a little bit more complicated that I don't want to go into just yet. But the big thing to understand about a basic function is that the the code is all written in between these two brackets. Okay, so you have a few different types of brackets that you use in code, and this is one of them. This is what we would call like a curly bracket. Okay, now the problem with C++ is that we can't really do much of anything without libraries with C++. So what we need to do is we need to import a library so that we actually have some functionality that we can actually use. Okay, and this is one of the things that makes it more challenging to actually teach somebody that's first starting out. So what I need to do is I actually need to include a library to be able to do almost anything with this. So the way to include a library is by using this hashtag, and then we'll type the word include, and then the name of the library that we're going to include is called IOStream. Okay, and IOStream means input and output stream. It's just some basic functions that'll allow us to print some data to what we call the console. Okay, so with IOStream, we're able to actually print out to the console, and I can actually look at the console by going to my menu to view into debug area, and then we will hit activate console, and we see this area down here at the bottom, and this will just be able to print some data out to us. Now, now we have a command that we're able to call in IOStream that lets us print out data to the console, and it's called cout or console out. That's essentially what it's called. Now, one thing that's helpful is when you're doing any sort of coding, you're going to be looking things up all the time, Googling things. And so I'm going to show you a couple websites that are helpful for me when I'm actually looking up code. So if I go into my coding, into C++, foundations. So there are two kind of main C++ references. So you have this one that's called CPP reference, which is pretty good. Now, if I type in cout into the search, one of the challenging things is that when you're first starting out, reading the documentation can be a little bit tough. Okay, and we see that here with this particular one. Okay, I'm not going to read this to you, but it's suffice to say that it may be a little bit challenging to read if you're first starting out. You're not quite sure what any of this stuff actually means. Okay, but as you get to read more documentation, some of this stuff will become more apparent. Okay, so I'm going to show you another one. So you got cppreference.com, and then you have, let's see, then we have c++.com/reference. So let's see what cout says here. So we see that, once again, kind of a complicated explanation. One of my favorite ones for looking up stuff, especially when you're first starting out, is one that's called Geeks for Geeks. And so I really like Geeks for Geeks because I love down to earth explanations for things, and this is a great one that kind of explains a little bit more in kind of plain English what we're doing. So what we could do is we could see the use of cout here, and it says a predefined object of OStream class, which we don't know what that means yet. And it says used to print the data of a standard output device. Okay, so what this means is that we can just take and we can actually just print something to the console. Okay, and we can do it using this STD, or what some people would call stud, or some people call it standard cout. Okay, so it doesn't stand for sexually transmitted disease in this case. It stands for standard. Okay, so the way that we can call this function is we could say std cout. Then next we have these arrow operators. I believe they're called insertion operators. So what this means is that we're going to basically take a line of text, and we're just going to output it to the console. So in this one, we'll say, I love audio programming. And then what we could do is we can put an end to that stream by putting another arrow operator, and then standard, and then end L. Okay, and what I could do is I can actually just compile this code by hitting this arrow up here at the very top left. It says build and run. So I'm just going to do that. And we see that it's printed I love audio programming to the console. Then it said program ended with exit code 0. Okay, so we aren't going to go into what that actually means yet, but it just means that the program ended successfully. Okay, so do you have any questions there so far, Alex?
Yeah, so what happens if you don't put the end L?
Yeah, so
Will it just,
so,
will it
let,
just print out everything in a straight line
so in
or in one line?
so in this case, so end line means that so in this case, what end line means is that that's the end of the line. So if I do another one and I say and audio programming loves me, so if we build and run this code, we see that this is on two separate lines, right? Now, if I take this out, let's see what happens. So see what happened there? So
Yeah.
so it's combined the two lines. So the end line command just tells you that you've it's just telling the console that we're ending the line there. Okay.
Okay. And can you output numbers?
Yeah, you can output numbers. So one important thing to know here is that I've put this in quotes. And what this means is that this is the literal kind of text that I want to output to the console. If I took those quotes away, what we'll see is that this will not compile. Okay, and the reason is because anything that you don't have in quotes, it's going to look in your C++ program and it's going to say, okay, I'm looking for something called something called love, something called audio, and something called programming. And of course, we don't have anything in this program that has that. And that's why that's in quotes. Okay, before we move on to numbers, I'm going to try to explain what this STD is about. Okay, so as I said before, STD means that it's part of the standard library. So this is something that if you're first starting out, you may forget, but this is called a namespace. Okay, so what this means is that this cout is a function. Okay, so it's basically an output function, and that is part of the standard library. Okay, so that's a little bit maybe too complicated to explain for this particular lesson. So now you said okay, well let's do, can we put out a number to the console? Okay, so we could do that a couple different ways, right? So one way we could do it is I could just type in a 1 here and I can build that and that will run. So we see that we have a 1 there to the console. Okay. But what if we had two numbers that we wanted to add together? Right? So like we had a 1 plus a 1, right?
We wouldn't put it in the string because string would literally output that expression.
Yeah. So you made a great point there. So you brought up a term that are viewers are not familiar with yet or may not be familiar with yet, called a string, right? So what's a string, Alex?
It's text.
Yeah, so
So
yeah, exactly. So string is a type of what we call, it's called a primitive. So we have these different primitives that we have in C++ that we can use to store data, right? So any sort of programming application is about giving instructions, and if we break that down a little bit further, it's actually about storing data and taking data and moving it around. And what we're able to do is we have these the most, what we call the most primitive data structures. So and then what we can do is we can build them into bigger and bigger and more complex things like characters, cars, and so on and so forth. But when it all comes down to it, it all comes down to these primitive structures that we're going to introduce to you over time. Okay, one of them is, do you know what a number, how we can represent a number in a C++ program, Alex?
int.
Yeah. Okay. So we have an int, and what is an int?
An integer.
Yeah. Okay. So an integer. Okay. And what's an integer?
A number. Any whole number.
Okay. So that brings up a great concept. So an integer is a whole number. Okay. So it's not a fraction. It's not a decimal. It has to be a whole number. Okay. Now we're going to introduce another concept that's called a variable. Okay. Do you know what a variable is, Alex?
Mm, Not exactly. I think it's something it stores something.
Yeah, right. Anything that we have inside our computer program is stored in memory, right? So it's stored somewhere in our computer. Now, in the technical sense, it's stored in a memory location, and the memory location has an address. And the address normally looks like something like EX0088A or something like that, right? So it's like this weird address. Now, that would be quite difficult to remember if you need to, because we're taking data, we're storing it somewhere, and then we need to actually go back and we need to get it if we want to do something with it, right? So, so what we're able to do is we're able to give these memory spaces names, human names that we can remember, and we can call them any. We can call them not everything, but nearly everything. So I can't call it int, right? Because int is what we would call a keyword that symbolizes that we're about to talk about a whole number. But I could call it int int a equals 2, right? So what I've done is I've declared an int, which is going to be a whole number, and I'm calling that whole number a. And then I've assigned it the value of 2. Now, what I can do is I could say a equals 3. And what that means is that that variable is now assigned the value of 3. Okay, or I can make it 3,000. Okay, now I can actually go back over here into my standard cout function, and I can just type a here. Okay, and I could just build and run it, and we see that the build has succeeded and that it has output the value of 2. Okay, let's create another int. We'll call this b, and we will say that this value is 5. Okay. Now, what I could do is we could print that out, and we can actually start to do something interesting here, right? So we could say, we can build this. We have a build succeeded, and now we have a 2 and we have a 5 there, right? Because A is 2, B is 5, right? So B is representing, if you think about it in a more technical term, okay, and this is good to think about as early on as possible. B is representing a memory location, okay, that's storing the value of this int, okay, and this particular value is 5. So the earlier that you can realize that these variables are actually representing locations in memory, the easier your journey will be. Okay. So now we have int a equals 2, int b equals 5. Now we can start to mix it. We can actually start to mix it up, right, with what we did before, where we had what we called a string, right? A thing of text. And I could say int a value. I could do this, right? Where I say, okay, I'm going to put what's called a string literal. Okay, that means it's literally a line of text. And I could do the same thing for here. Okay, where I can say int b value. And then I will print this. And we see that we're getting this printed out to the console correctly. Okay, but if I take, what do you think will happen if I take this b and I put it inside these quotes? Alex, what do you think will happen then?
It'll just put out that exact string. So it won't output the number, it'll output B.
Yeah.
It's B value
Yeah.
B.
Exactly. Because it's in these quotes, it's saying, okay, I'm just actually outputting this string. I'm not actually looking for a variable called b, right? So as Alex said, if I do that, then all I get is literally the letter b. Okay, so now let's go back. And what do you think will happen if I put C here instead of B?
It'll give you an error, as it says right there. There's nothing in the program for C. So
Yeah.
it'll give you an error.
Yeah, exactly. So anything that you put in your C++ program that is a letter or that's a word, it's going to look in your C++ program and it's going to look for C or whatever you put in there, right? And it's going to say, hey, you didn't declare anything called C. And that's exactly what this error says. Use of undeclared identifier C. Okay? So, but if I said int C equals 10, now the error will go away, right? Because we have a C now. Okay? And we can change this to a C, so this is all correct. Okay?
Now can you set ints equal to other ints? So can you set C equal to B?
Yeah, so let's try that. Right? So I say int C equals B. And now what will C equal?
C will be 5,
Yeah,
or whatever B is.
exactly. C will be whatever B is. And that's what we have, right? But as I said before, we can actually reset the value, and then that's what we do
So
there. Yeah, so now it's 6, right?
so I noticed that you didn't put int before the C because you already declared C.
That's right. Yeah, so once it's declared, so here we're actually creating it, right? We're doing what's called allocation, where or where we're actually creating an int, and we're calling that memory space C. And that's not literally what that memory space is called, but we're just naming that C so we can remember it when we want to go back to it later. So once that's created, then we actually can't create it again, right? So I'll show you what I mean here. So if I say now int C equals 6, let's see what happens. We get an error, right? It says redefinition of C. It says, hey, you already have a C. You can't create another one called C. Okay, I could call it D. I could call it whatever I want. I just can't call it C again because there's already a C. Okay, so that's going to be the end of the lesson for today. So let's pull back up our lesson plan. So we talked as best we could about what audio programming is. We talked briefly about why we're using C++ for audio programming. We talked about downloading a place where you can actually type your code, an integrated development environment. We talked about the structure of a basic C++ program. We wrote our first C++ program, and we talked a little bit about the standard namespace and about the function cout. Do you have any questions?
No, I think everything was pretty clear.
Okay, great. So that's it for this tutorial. And then in the next tutorial, we will talk a little bit more about ints and how we can actually do mathematical operations with them, how we can add them, subtract them, multiply them, and divide them. We'll also go into numbers that aren't whole numbers, so floats, and we'll talk a little bit more about the string primitive. Okay, so thanks for joining us today, and I will stop sharing my screen so we can say bye. So we're going to try to do these on a regular basis, and I hope you enjoy them. And if you have corrections, so one thing that I will say is that I am not the C++ expert. Okay, so I know enough to do some C++, and I know how to write C++, but I'm not the expert. So if there are any corrections, please feel free to correct me in the comments, and I'm happy to take your feedback, and we will continue on with these. And welcome to the start of your journey into being an audio developer, Alex.
Thank you. It's going to be a long one.
That's it. That's it. But every journey starts with a single step. I have confidence in you.
Thank you.
Great. And we will see you next time.
Appreciate it. Speak soon.